Neural networks are a fundamental component of artificial intelligence, AI, and machine learning, ML, systems. They are mathematical models inspired by the structure and functioning of the human brain, specifically the interconnected network of neurons. Neural networks are designed to learn from data and make predictions or decisions without being explicitly programmed for specific tasks. At their core, neural networks consist of interconnected computational units called artificial neurons or nodes. These nodes are organized into layers, typically including an input layer, one or more hidden layers, and an output layer. The connections between the nodes, known as synapses, have associated weights that determine the strength of the connection. The network's architecture and the weights of these connections are learned through a process called training, which involves presenting the network with a large amount of labeled data. The training process in neural networks is typically performed using a technique called backpropagation. During training, the network receives input data and produces an output prediction. The predicted output is then compared to the desired or expected output, and the network's performance is measured using a loss function, which quantifies the difference between the predicted and expected outputs. The goal of training is to minimize this loss function by adjusting the weights of the connections iteratively. Backpropagation works by propagating the error backward through the network, computing the contribution of each node's activation to the overall error. The weights are then updated using gradient descent optimization, which adjusts the weights in the direction that reduces the error. This iterative process continues until the network's performance reaches an acceptable level or a predefined stopping criterion is met. Once trained, neural networks can be used for various AI tasks, such as classification, regression, and pattern recognition. For example, in image classification, a neural network can be trained to recognize specific objects or patterns within images. In natural language processing, neural networks can be used for tasks like sentiment analysis, machine translation, and text generation. One of the advantages of neural networks is their ability to learn complex and nonlinear relationships from data. By leveraging the hierarchical structure of multiple layers, neural networks can capture and represent intricate patterns and features that may not be easily discernible by traditional algorithms. This makes neural networks particularly effective in tasks involving large amounts of data, such as image and speech recognition. There are various types of neural networks, each with its own architecture and characteristics. Some common types include feed-forward neural networks, convolutional neural networks, CNNs, for image processing, recurrent neural networks, RNNs, for sequential data, and generative adversarial networks, GANs, for generating new data. Neural networks have found applications in numerous domains, including computer vision, speech recognition, natural language processing, recommendation systems, autonomous vehicles, and many others. They have revolutionized AI by enabling machines to learn and perform tasks that were previously challenging or impossible using traditional programming approaches. However, it's important to note that neural networks are just one part of the broader field of AI and are often combined with other techniques and algorithms to build more sophisticated and intelligent systems.